We're always looking for ways to build smarter AI. But what if the best classroom in the world wasn't some perfectly clean, curated data set? What if it was just the internet itself? Imagine an AI that could learn about our world just by watching millions of us explain how to do things on YouTube. Well, that's the incredible idea we're diving into today. It really all boils down to this one huge question. I mean, for you and me, watching a video is second nature, right? We see someone baking a cake, and we just get it. We understand the steps. But for a computer, a video is just a gigantic, overwhelming stream of pixels. So how in the world do you teach it to connect those pixels to actual meaning, to understand what's really going on? Well, for the longest time, the answer was basically brute force. You'd have teams of people sitting there manually labeling everything frame by frame. This is a person slicing an onion. This is a car making a right turn. And as you can probably guess, this is painfully slow. It costs an absolute fortune. And when you think about the sheer amount of video out there, there's just no way that approach can keep up. It doesn't scale. And this brings us right to our first major concept, what researchers call the annotation bottleneck. It's the official name for that massive roadblock we were just talking about. It's really the biggest thing that's been holding back progress in teaching AI how to see and understand our world. And hey, don't just take my word for it. The researchers behind this very paper put it pretty bluntly. They said the whole process is, quote, cumbersome, expensive, and not scalable. So we're not talking about a small hiccup here. This is a fundamental, deep problem that was just begging for a totally new way of thinking. So what is that new way of thinking? Well, welcome to the new classroom, YouTube. Yeah, that's right. Instead of these perfect hand-labeled video clips, the idea is, what if an AI could just learn from the huge, chaotic, but unbelievably rich library of videos that already exist? It's a massive, it's a messy, but it's an incredibly promising new approach. And to make this happen, the researchers put together a dataset they call How-to-100M. This scale here is just mind-blowing. We are talking about more than 100 million video clips, each one with its original narration, all scraped automatically from instructional videos. So just think about every how-to video you can imagine, from fixing a bike to cooking a recipe. That entire universe of knowledge, that's the AI's new textbook. But as you'd expect, this textbook is messy. And that brings us to the core challenge, misalignment. The words people say almost never line up perfectly with what they're doing on screen. You know how it is. Someone will say, okay, now we're going to cut the wood, a few seconds before the saw even gets near it. For a human, that's totally fine. We get it. But for an AI trying to learn, that's super confusing. And this is not a rare occurrence. We're talking about a huge problem. The researchers figure that about half the time, a full 50% of the time, the narration and the action in a clip are not perfectly in sync. So any new learning method has got to be smart enough to deal with that massive amount of noise. Okay, so we've got a gigantic, messy data set and this huge misalignment problem. So what do? Well, enter the hero of our story, a really clever breakthrough method that the researchers came up with called MIL-NCE. This technique is designed specifically to learn from exactly this kind of noisy, real-world data. So the real genius here is a shift in thinking. The old way would assume that this specific video clip has to match this specific sentence of narration, which we now know is often wrong. The new idea is way more flexible. It says, hey, this video clip probably matches one of the sentences spoken nearby. That gives it a much, much higher chance of actually finding the correct link. So how does it actually work? Well, you can think of it as a two-step process. First, it gathers the clues. Instead of looking at just one sentence, the AI considers a whole bag of nearby sentences as potential matches. That's the multiple instance learning part. Then, step two, it learns to spot the real match. The AI gets really good at picking the true video and narration pair out of a lineup that includes a bunch of random fake pairs. That's the noise contrastive estimation part. You put them together and you get an AI that's amazing at finding the signal hidden in all that noise. Okay, so that all sounds really smart in theory, but the real question is, does it actually work in practice? Let's take a look at the results. And the answer is a huge yes. First, they tested it against other AIs that also taught themselves without any human help. And on a standard test for recognizing actions in videos, this new method came out on top. It became the new state of the art. But honestly, Here's the part that really blew my mind. They put their self-taught AI up against a different model, one that was painstakingly trained by humans on a huge, expensive, hand-labeled data set. And the result? The AI that taught itself by watching messy YouTube videos actually beat the one that was carefully spoon-fed all the answers. That is a game-changing result. And it's not just a one-trick pony either. They tried it on a totally different task, video search. You give it a line of text and it has to find the right video clip. And the results here are even more stunning. This new model, using absolutely zero human labels, more than doubled the score of the previous best method, all just from listening to what people were saying in their videos. It's just incredible. So yeah, the numbers are really impressive. But let's zoom out for a second and think about why this really matters. What does this all mean for the future? Because this isn't just a small step forward. It really points to a whole new way of building artificial intelligence. What a breakthrough like this unlocks is just huge. For starters, it gives us a way to train incredibly powerful AI without that expensive, slow, manual labeling process. That's a big deal. It also means we're going to get much smarter systems for things like video search, analysis, and summarization. But really, the biggest thing is that this is a major step towards an AI that can learn from the messy, real world, kind of like how we humans do, just by watching and listening and figuring things out on its own. And that leaves us with one last really fascinating question to chew on. We've just seen that an AI can learn to understand the world by watching our how-to videos. So if it can master all of those skills, what's it going to be able to learn next just by watching us? The possibilities are pretty staggering to think about.